For this first lesson, we'll learn about fields and energy. When it comes to the word field, what comes to mind? Perhaps a field of grass? What about gravitational or magnetic fields? Well, it turns out these are all related. If you watch a field of tall grass on a windy day, you may notice that you can see gusts of wind propagating through it. Diagrams of magnetic and gravitational fields are similar. Fields are essentially a map of direction and intensity at a point in time. In the case of our windy field of grass, the field we are mapping is the wind. In the case of gravitational fields, it's gravity. And in the case of magnetic fields, it's magnetic forces. Energy is what moves through the field. In the case of our grassy field, it may be a leaf. For gravity, an object in orbit. And for our magnetic field, a magnetic particle. The modest theory states the universe arises from energy propagations displacing other energy. From this, fields and a fractal pattern emerge that explains everything that we've ever observed. So to give an example, I've thrown together a bunch of random noise into a paint program. So here we have 4 layers stacked on top of each other. You can think of each layer as being like a field in our stack of fields. So for example, if we disable all the layers except for one, we can see that it looks like this. And as we start adding layers, you get this end result. Now, right now we're extremely zoomed in. So if I'm energy propagating through this, I might take the path that is the lightest. If we zoom out, and I am energy that is bigger, I'm going to take the path that is on average following the lightest. Of course, energy and everything is actually invertible. So while one energy in one context might follow the light path, energy in another context might follow the dark path. And what we can see is that as things move, this is going to influence the path that energy takes. And if I don't respond to that layer, I'm not going to respond to that movement either. If you zoom out even more, then our idea of what is light and what is dark is again going to change because what we respond to is going to be different. So in this case, at this zoom level, I might mostly ignore all of this area because it is generally just kind of a grayish color. But maybe I view these dark areas as areas that I would be repelled from and turn away from. So here we could have energy that moves through here. And maybe as stuff moves, it moves too. Now, one thing that's missing from this example is that the energy isn't actually displacing the energy around it, which is a key part of the modest theory. The question is, we have this layer of noise. What is this noise made up of? And the answer is, it's other energy. Looking at the simulator/sandbox, that is theoryofeverything.io, then when we look at a field like this that is neutral, it's similar to that grayish area. It's just on average not really doing very much with energy as it goes through it. So then when we place one, it's just going to keep on moving the direction that it was in. And what we do notice is that as this energy moves, it is pushing things out of the way, and that creates an area of more density up here and less density in the middle. This allows small imperfections to be amplified in the middle and for there to be an effect where it is bounced back and forth between the areas of the higher density. Now we can change the physics of our field to make it reflect how you have those different overlapping layers of energy and how they affect this particular energy propagating through it. Now, one of the things that you can do is change how energy reacts to the field itself. So energy displaces the field and we make that as part of the field physics. And we have that here. But energy also can you can change how energy reacts to it. So energy field steering right now is set to basically a gravity-like. So you can place some energy, and then you can place some energy that actually reacts stronger and will turn sharper. And so you can see the difference between the two. You can also place energy that reacts like anti-gravity, so it turns away from gravity. When you think about charge, this is a great way of modeling charge. So you have like a charged field, and one polarity is going to be aligned with the field, and one polarity is going to be repelled by it. So you can see as we have a little bit of mass starting to form, we can take this and shoot our anti-gravity into it, and it doesn't want to go into it. There's one more thing that might be confusing you, which is that you never see energy change its speed. Well, the speed of light is fixed. It also doesn't change its speed. So in this field of vectors, which are both an intensity and a direction, as far as the energy is concerned, it's actually a field of directors. So it can only know which direction to turn. Now you can change the speed of energy, it just won't change while it's running through the simulation. And what you'll notice is that energy that operates at different speeds will actually interpret the field differently. Different areas will be more or less effective to it depending on the speed that the energy operates at. So here you can see that energy that is moving too fast won't get captured by this mass here. And in some cases, you can get an orbit. Thanks for watching the first lesson. Hopefully you now know enough to get started using theoryofeverything.io. To recap, we are modeling energy propagations through a field of directors. This is part of the universe's fractal pattern, so what energy actually is, and what the field actually is, will vary. You can use the controls to change the properties of the field and newly place energy. Have fun, and see you at lesson 2.